to look at, like I said, is the parent function. So whenever you're dealing with the different types of functions, a lot of times they're referred to as the different families of functions because certain types of functions all have very similar behaviors. And those functions have the same parent function. So who in here has siblings? Okay. Now, are you and your siblings the exact same? No. Okay. Because whenever, like, your parents' genetics combine, right, and they split into you and your siblings, right? Like, you all get different features of each of your parents. So just like that, a parent function can have different features be applied to it, and it completely change what it looks like, where it's at, things like that, but it still has that same core feature to it, if that makes sense. So what we're going to do is we're going to look at the parent function. So to do that, we're just going to plug in some points and see what we get. What is the absolute value of negative 2? 2. So we're going to put a point at negative 2, 2. What is the absolute value of negative 1? 1. So we're going to put a point at negative 1, 1. What is the absolute value of 0? 0. So we're going to put a point at 0, 0. What is the absolute value of 1? 1. We're going to put a point at 1. What's the absolute value of 2? 2. So we need to put a point at 2, 2. So this right here is our absolute value graph. It is a V, just like that. Okay, now that graph goes on forever because you can take the absolute value of anything, right? What's the absolute value of negative 72? 72. What's the absolute value of 512? 500. What's the absolute value of negative 72,000? 72,000. Yeah, exactly. Okay, it goes on forever. Okay, we can just only fit so much of it on our picture. Okay, so what is this point of the graph? Does anybody know? It is the origin, but I'm talking the what? The vertex. Okay, so the vertex is where those lines connect, right? And so what is the coordinates of the vertex here? 0, 0. So in the parent function, in the most simplest form, the vertex is at 0, 0, right? Stop it. I'm going to move one of you. Okay? So, now, domain. Does this graph ever stop going to the left? No. Does it ever stop going to the right? No. So, what does that mean for our domain? Infinity. So, it's negative infinity to positive infinity. And that is going to be true for all absolute value functions, regardless if they're the parent function or not, because the graph's going to go forever, always. But the range does change, okay? So if we look at this, range goes our y values from bottom to top. So where is the bottom of this graph? Parentheses or bracket? Bracket. Okay, then does this ever stop going up? So that means to infinity, okay? So as we're looking at this, that point right there is our vertex. And an absolute value function also has something called an axis of symmetry. What does the word symmetry mean? Same on both sides. So if we look at any absolute value function, we can see that on both sides of the origin, it's the same, right? So there is a imaginary line that cuts through the middle of that, through the vertex. That is called the axis of symmetry. And it is just a vertical line through the vertex. That's all it is. And it's just important to remember that on both sides of that, it's going to be the same. So as we look at this, we are going to graph some absolute values. We're going to talk about the ways that absolute values are transformed, the things that we can do to the parent function to make it different, to make it into the different functions that we see. So I'm going to pull up the graph that we were going to look at on Desmos. Hopefully it will work and not kick me back out again. You're not going to work, are you? Come on. There it goes. Oh, dang it. Okay, let's see if this. Yes, I want to use that account. Lovely. Okay, we're just gonna close it and we're gonna try it again. So how was the food y'all ate last week? What was your favorite thing?
Mac and cheese.
Mac and cheese is a good option. What else?
That's all I eat, macaroni.
That's all you eat?
Yes.
Together? Like, you mean like mix them together?
No, like
Just
the
let
bottom
it-
touch each other just a little bit.
No, I'm
I'm one of the people that doesn't like my food to touch. I'm a
I don't like
weirdo.
nothing else to touch when it yams and the macaroni.
How do you not make a Thanksgiving plate touch? You have so much.
Yeah, Thanksgiving's difficult, but it's usually fine because things go together. But like, you know, there's some things that I'm really like. But anyways, now we're good to start working on this. Okay. So this is the activity that we were gonna do today. So you know, this was like, where are you at today? Which
hold on, I'm all the way to the other side. Yeah, right there.
I like that one too. That one's my personal favorite. Then I also like that one.
I'm sorry. I'm
like
just
that
kidding.
one.
No,
Oh, that
right
one.
there,
This
right
one?
there.
Yeah.
What's on the end?
The very end, I think it's just this one. Yeah.
It's like the line.
I do think that one's my favorite though, personally. It's just this morning I was this when none of my technology would work. That was where I was at this morning. I was not very happy. I literally told first period, I was like, if y'all don't be quiet, I'm gonna yell at you and I'm so sorry. This isn't your fault. It is my fault. But now, so what we're gonna start with is we're gonna talk about transformations of functions. Okay? So when we look at this, we're going to start by looking at what happens when we add some number k to the end of it. Okay? So when we look at this, a, h, and k are just like placeholders for the numbers we could put there. Okay? So when we look at k, what happens when I make k positive, when I add a k?
Go up.
It goes up. What happens when I subtract a k? Goes down. Okay, so k is the vertical shift of the function. So what we're going to do is on here, we are going to write vertical shift.
Can you say up and down?
We're going to put that, but I want you to put vertical shift. Okay, I want the... So it is a vertical shift, but then positive k goes where? It goes up k units. Okay, what about negative k?
Down.
It will go down k units. We say that because we want, when we answer it, if it was like 5, we want to say it goes down 5 or it goes up 6. We want to make sure we're specifying how it's changing. Now, we're going to look at some examples of these. So, I'm going to put that back at 0. So, if we look here, it says the red graph is y equals absolute value of x. So, it's our parent function. Describe how the graph y is equal to the absolute value of x minus 5. So, how has the blue function changed from the red one? It went down 5, right? We can see that from the graph and from the minus 5 on our equation. What about this one? It says absolute value of x plus 3 is the blue. How has it changed from the red?
Up through.
Up 3. Now, without a graph, what is the change that the absolute value of x plus 8 has?
Up 8.
Up 8. Absolute value of x minus 12.
Down 12.
So if I wanted to take and write a function to make that dashed line match the red one, what would I need to do?
No.
If we go minus 2, it goes down. So what do we need to
Oh, with
do?
the dash line, you see the up?
Yep,
Oh, the plus.
plus 2. Okay? So whatever we add or subtract is going to move our graph up or down that many. When it moves up or down, what part of it is it specifically moving? The vertex. So when we are looking at this part right here, our y value of our vertex is directly changed by whatever k is. So for this one, what would we need to do to make the dashed line match the red one? Minus 4. Okay, now we're going to look at h. So h is inside of the absolute value part. Okay, so whenever it is inside of our absolute value, okay, it's a little bit different. So if you had a guess, what do you think would happen when you had a positive h?
It'd go to the
On the left.
I would go to the right.
Which way does it go?
Left.
To the left.
Negative and negative.
Okay, the reason for that, okay, is it has to do with whenever we solve these equations. So whenever we have this, if we look at this graph, you'll have to ignore my shoes, they're very squeaky today for some reason. So what is the y value at this point? The y value. 0. Okay, so our graph, this would have to equal 0. What number could I put right there so that it equals 0?
-7.
So negative 7 plus 7 equals 0. Where is negative 7 at? Is it on the right side or the left side? The left side. So that's why when it's positive, it moves left. Because you would have to use a negative number to make it 0. Okay? So same thing here. If it is minus 4, what would I need to plug in right here to make it equal 0? Positive. And so that's why it would go, and which side of our graph is positive 4 on? The right side. So it has to do with what makes the graph equal 0 and why it changes a little differently. Because essentially it's you just solving the inside of this equation. How would I solve the inside of that equation?
Move 4.
Add 4 on both sides. So that means x equals 4. And where is 4? It's on the right. So that's what's happening whenever we have our h in there. That's why it feels like it's backwards, but it's really not. It just feels weird. So when it's positive, it goes to the left, and when it's negative, it goes to the right. So if we were to look here, we have the absolute value of x minus 5. How has that been changed? Goes to the right. Yep. What about this one? Absolute value of x plus 6. Goes to the left 6. This one we have the absolute value of x minus 2. Goes to the right 2. Absolute value of x plus 4. Left 4. So in order to make these match, what would I need to do? Okay, how would I do that?
-7.
Do I need to subtract 7 inside or outside of the absolute value?
Inside.
Inside, because if I did it outside, it goes
It goes
down. Inside, we'll move it left or right. And there, we're good. So what about for this one? What would I need to do to make these match? Plus 3. Okay. So now we are going to write in on our paper. So the h, if up and down gives us a vertical shift, what does left and right give us?
Horizontal.
So we're going to put our horizontal shift. And so a positive h moves us where? So left h units. Negative h gives us right h units. And it directly affects which coordinate of the vertex? Okay, the last part that we're going to look at is what's in the very, very front. So we use A for a placeholder for anything that goes in front. Okay, so the first thing we're going to look at is what happens if we have negative A. So if we have a negative A, if your line, if you have just a regular old line and it starts by going up and you make it negative, where is it going to go? So what do you think is going to happen to our absolute value? It's going to flip and go down. And so if we look here, we make that from positive 1 to negative 1. All that changes is that it goes down. Does the location of the vertex change? No. So there's a really silly way to think about that. And so if you're standing here and you put your arms up in a V, your head's the vertex, right? If I make it negative, does my head move? No. Okay? If I'm standing here and I go left 3, did my head move?
Yes.
Yeah. It moved left 3, right? If I go down 2, did my head move?
No.
Yes. Okay? If I go up 7, I can't go up 7, but it moves, right? But just moving where the arms are doesn't change where this is. You have to move the whole thing to move the vertex. So whenever we look at anything with A, okay, that is, we're just looking at what's happening with those arms of the V. Yes, ma'am. So for negative A, that causes it to reflect across the x-axis. And now we're going to talk about what happens when A is a number other than 1. Okay? So if there's a negative in front, it reflects. Okay? But now we're going to talk about what actually happens when there's a number there. So we're going to talk about when the absolute value of A is greater than 1. And we're going to talk about what happens when 0 is less than the absolute value of A, but the absolute value of A is less than 1. So it's in between 0 and 1. We're going to talk about those two cases. And we're going to look and see what happens. I'll go back in just a second. So if we look here, when A is 1, that is our parent function. It's just hanging out. What happens when A gets bigger?
The slope changes.
The slope is changing. It gets steeper. It gets skinnier. It's getting taller and skinnier. Essentially what's happening is you're taking the height of the parent function and you're multiplying it by 2. So like if we take Kelly, what would happen if we multiply just your height by 2? Not your weight, not your size, just your height.
She'd be 2 times taller.
But what would happen to the rest of her?
It would be elongated.
You're like gonna stretch out and get like really, really tall and skinny, right? It's gonna look really silly, okay? That's kind of what's happening to this graph. It takes it and it goes whoop and stretches it out. So when A is bigger than 1, we have a vertical stretch, right? That is a vertical stretch. Let's see if I can tweak this so we can see it. 0. Okay, it's not doing it. Dang it. Okay. Okay. Now, so here we have a vertical stretch of what? 2. And basically essentially all we have that's going on here, okay, is our parent function. It goes up 1 over 1, right? Our slope of that side would be 1. What would the slope of the new function be? 2. Because it goes up 2 over 1. So your A is directly affecting the slope of those lines of the side of the V. So now we're going to look at what happens if it's smaller than 1. We know what happens when it's negative. When it's negative, it just what? Flips. But if it's in between 0 and 1, like 1/3, what does that do to the height? It's not a horizontal stretch. It's still a vertical, but it's going to be a shrink.
Oh.
So let's think about it this way. If we have a 6'5", 200-pound NBA player, it's a big old person, right? And we multiply just their height by 1/4. So they suddenly become 1/4 of 6'5". What are they going to look like? They're still 200 pounds. We didn't change their weight. We didn't change anything about them. But what's going to happen to them?
Very large.
They're going to,
Compact.
yeah, they're going to kind of turn into more of the shape of a basketball, right? If you just smushed them down, right? It wouldn't be great for that. It would not be great for that 6'5" NBA player if you multiplied their height by 1/4. Okay? Would not be great. Okay? That's kind of what's happening. That's going to be a vertical shrink or a compression. We're taking and smushing it down and making it shorter. Okay? So if we look at this, what would the slope of that new line be?
1/3.
1/3. It goes up 1 over 3. Okay? And so anytime it is between 0 and 1, it is a vertical shrink or compression. So it is a vertical shrink. Or you could think of it as a compression. It is just smushing that graph down like it would smush an NBA player. And all of the things with A, do they affect the vertex at all? No. What's affecting your vertex is that moves left, right, and up and down. Okay? All A affects is what's happening to the arms of that V. Connor, set up. Thank you. All right. Now, we're going to look at some examples of these. We're going to go through the odds together real quick. So for number 1, we have a transformation of +2. What is that causing to happen?
Go
Up 2. So what does that make the vertex?
It's still the same.
No, it's +2.
Wait, it's 0, 2.
0, 2. Okay? For number 3, what is the transformation of -1 caused to happen?
right 1.
Why is it right 1 and not down 1?
Because it's inside the...
Because it is inside. And so what is our vertex going to be?
1,0.
Yep. Okay, for number 5. How many transformations are in number 5?
2.
So we have -2 and we also have +1. What does -2 cause to happen?
Right 2. Up 1.
It goes right 2 and it goes up 1. So what does that make our vertex? 2, 1. Now I want you to do 2, 4, and 6 for me real quick. Oh my. All right, for number 2, what is our transformation? Down 3. It is that -3, and it's going to cause it to go down 3. What does that do to the vertex? 0, -3. You have to do the negative 3 because it's going down. Okay. For number 4, what is our transformation? What is that going to do to our vertex? All right. For number 6, how many transformations are in number 6? 3. What is the first one we see? That minus sign in the very front is going to cause it to reflect across the x-axis. Okay, then what else do we have? Left 3, I agree. And down 5. And what does that mean our vertex is? -3, -5. So now we're going to look at the back, and we're going to do a couple more of these. Okay, for number 7. How many transformations are happening on number 7? Let's really think about it. It is 2 because the negative is there, but we also have a number that's bigger than 1. So both of those things will affect it, okay? So what does just having the minus sign in front do? Flip it, okay? That's going to cause it to reflect. Okay, but what does that 3 being in the front cause to happen? So it gets flipped, and then what's going to happen to it? It's going to stretch, okay? It's going to have a vertical stretch. Yes. And it's going to be a vertical stretch by the factor of 3. Just means it's being multiplied by 3. Okay, does either of those things affect the vertex? No. So what is our vertex?
0.
All right. Number 8. What is our transformation? Vertical shrink. By what? Does that affect the vertex?
No.
So what's our vertex?
0.
Now I want y'all to do 9 and 10. They both have 3. So what is our transformations?
Vertical stretch.
Right 1, down 7.
And our vertex is?
1,
-7.
-7.
1, -7. Okay, what are our transformations for 10? And so what will that mean for our vertex? -3, 4. Okay, if it goes left or down, you have to make sure to put that negative in front. Okay. Yeah. So we're going to take a few minutes and we're going to go ahead and start the next section, but just a little bit. Okay, so now we're going to look at graphing absolute value functions. Okay, so we have some steps. As we go through the steps, we're going to do this first problem, this first example. Okay, so the first thing is to identify the transformations and the vertex. That's all we've been doing. So what is the transformations for this first graph right here? Up 1. Okay, we have +1, which causes it to go up 1. What does that do to the vertex? 0, 1. Okay, that is step 1. We can do that all day long. We got it. Step 2, you place the vertex in the middle of the table. And then we're going to find other points around it. What is 1 point smaller than 0? Smaller than that? Okay, bigger than 0. Bigger than that? Okay, that's the points that I'm going to plug in. I'm just going to plug those numbers in to this equation. So what is, if I plug in right there, what is the absolute value of -2? What is 2 plus 1? So that's one of our points. So -2, 3. What is the absolute value of -1? 1. What is +1? 2. So we're going to go to the point -1, 2. Okay, we already know our vertex. What is that? 0, 1. If I plug in 1, what's the absolute value of 1? +1? What's the absolute value of 2? 2 plus 1 is 3. And we have our graph. So another cool thing about this is once you find the first half of your points, they are just duplicated on the bottom. It's the same thing. It's a mirror image of both sides. Both sides are going to be a mirror image. Okay. So let's go ahead and look at number 11. What is the transformation happening on number 11? Yep. It's getting reflected across the x-axis. So what is our vertex? 0, 0. Nothing changed our vertex. That goes in the center. What would be 1 point smaller than 0? 1 point smaller than that? 1 point bigger than 0? 1 point bigger than 1? Okay, from here, we're just going to plug these in. Okay, what is the absolute value of -2? 2, but you have to make it negative, so it's going to be -2. What's the absolute value of -1? But if you had to make it negative, it's going to be. So without even plugging in, could I find the last two?
Yes.
What would this point here be? -1. And what would this point here be? -2. Because it is symmetric. That means both sides are going to match. Okay. So we can also do it by just plotting our origin. And if I look at A directly tells us what our slope needs to be. So in this problem, what is A? -1. So it's going to go down 1, over 1, down 1, over 1. And I know the other side has to match. So we have multiple ways we can look at graphing these. All right, let's go ahead and do, we're going to actually stop there. Okay, we will pick up on number 12 tomorrow.